Hello everyone, in this video we're going to be talking about the area of a triangle using the stuff that we've been doing in this trig unit over the last couple of weeks. Let's start with looking at a triangle that is right-angled. Now back in semester 1, I hope that everyone remembers, we spoke about the formula for the area of a right-angled triangle. We got this formula by realizing that a right-angled triangle is really just half a rectangle. I'm not going to go into all of that now, but hopefully everyone remembers that we decided that the area of a right-angled triangle is a half times the base times the height. So that's going to be our starting point today in this video, where we're going to work out the formula for the area of a triangle that is not right-angled, like this triangle that I've drawn over here. So let's think about how we would do this. In this formula, where I've got a half times the base times the height, there is a very important caveat to this formula, which is that the height, this h over here, has to be the perpendicular height of the triangle. And if you remember, we spoke about what that means, the perpendicular height, meaning the height of the triangle that creates a right angle with the base. So if we have a right-angled triangle, then the height is going to always just be one of the lengths, the side lengths of the triangle. However, if we have a non-right-angled triangle, like this one here, then the height is going to be the length of that dotted line there, because that is the line that creates a right angle with the base. So let's think about how we can use trigonometry to find the area of this triangle. We're going to start by labeling the side lengths and corners of this triangle using a pretty common way of doing that, and that is that each side length is going to be labeled with a lowercase a, b, and c. And then the opposite corners, so the angle that is opposite each side length, is going to be labelled with the capital letter of its corresponding side length. So the side length opposite the B side, that's going to have angle capital B. This thing here will have angle capital A, and this will have angle capital C. Okay, so we've got our triangle that has side lengths A, B, and C, and angles A, B, and C. Let's think about how we can find the area of this triangle. The first thing we need to do is think about what is going to be the length of h, this perpendicular height here, which I'll now fill in and draw as a solid line. Well, we can use trigonometry for that, because notice that now I've created a right-angled triangle here with side lengths h and a hypotenuse b and an angle here c. So if I take those three things into account, I can use the trigonometric ratio of that involves an angle, the opposite side, and the hypotenuse. So which is the one that has the opposite and the hypotenuse? That is sine, because we know that the sine of an angle equals the opposite over the hypotenuse. So in this case, we know that sine c, where c is my angle there, equals the height, h, divided by the side length, b, which in that right-angled triangle is my hypotenuse. Let's rearrange that to get what h is. So if I multiply both sides of this equation by b, I'm going to get that b times sine c equals h, or I'm just going to write that as h equals b sine c. Cool. Now we can write a formula for the area of a triangle. So if the area of a right-angled triangle is a half times the base times the perpendicular height, that is really just the formula for every triangle, except that if it's not right-angled, then we need to substitute what we've just worked out to find what this perpendicular height is. So if the area of a triangle equals a half times the base, where in this case, the way that I've labelled this triangle, the base is A, times the perpendicular height, where we've just worked out that the perpendicular height is B times sine C. And so I get my result, and I'll write this at the bottom here and kind of put it in a box, that the area of any triangle equals a half times A times B times sine C. Now we're going to have a closer look at that formula and do a couple of examples of it, and that will be in the next video.